So let's give a big hand to Matt.
So Brian preempted with the mantis shrimp and the pistol shrimp. Did you find out about those from Octonauts? No. Okay, that's where I can get all my zoology from. Today I'm going to talk about octopi, spiders. It's about as close to the web as I'm going to get, probably. Hawks, but I haven't moved on from puppies. They're still there. I usually at this point just let this wash over you, lull you into a false sense of happiness and security before anything terrible happens. And the last animal I'm going to talk about, which they want you to believe isn't real. It isn't real. I'm not one of those flat earth people, I think. Centaurs. Hello, I work at Google AI. I'm a designer. I should wear this T-shirt all the time. This is not the official Google feature. My views are not representative of me half the time. And while we're in the sort of disclaimers and warnings, most people were like thanking collaborators, or I'm just like warning you. Does anybody react badly to flashing images or lights? Okay, good. Who has one of these drawers at home of like, okay. This talk is a bit like that drawer you have. It makes no sense. Most of the other people in your life want you to throw it away. But you're saying, no, there's something useful in there that we'll need one day. So if you treat it like that, we might come out of this alive. Who here has some kind of knowledge or understanding of machine learning techniques, particularly sort of neural networks? All right, not too many hands. So I will illustrate it with a cat GIF. The cat has disappeared, unfortunately. But most of the advances in, first of all, I'm going to talk about that terrible word AI a little bit. We are called Google AI, but most of the things in there are based around advances in machine learning. And the guy who's the head of Google Research and Research and Machine Intelligence until very recently, he went to Apple. John Giandria, he said to me, he said, like, actually, any time you see somebody say machine learning, machine intelligence, AI, if you talk about learned systems, then you'll get to the bottom of it. And also, it will help a lot because those are two words which just send people to sleep, particularly after lunch. Learning and systems. Oh, God, that doesn't sound very exciting. Artificial intelligence sounds much more exciting. Learned systems, systems that are that achieve their goals through learning through example, generally, rather than being explicitly programmed by a human. So in this case, this is a learned system which is trying to discern between a cat and a dog. It has been trained to recognize this by generally, in the sort of vast majority of these systems, using a form of machine learning called supervised learning, where thousands, millions of images of cats or dogs will be ingested by the system and labeled as a cat or a dog, and then that learning is then imprinted into the system, into these neural layers, to create this kind of, there are 5 layers here. Usually there's sort of 500,000 or 5 million, many, many layers of this kind of like neural, electrical, pachinko, pinball, where input from the outside world through, in this case, a camera lens or a photograph, is going through these layers of inference, these layers of learning, and the pixels, the photons are compared pixel by pixel, and these layers go cat, dog, cat, dog, cat, dog, until you get to the output of, well, I said it was a cat GIF, it's actually a dog. There we are. So if you have that in mind, that's kind of basically where all of this stuff has come from. They're learned systems, they are trained on a ton of data, and then the inference, the output, is done through the layers of learning that are built up through that process. I work a lot with the hardware PA that Nina's also in Google, and we work on putting these sorts of machine intelligence operations into hardware, into Google's hardware. One of the projects that my team sort of did from inception was this product, Google Clips. I have it here. I'll show some of you a demo of it at the break. It is a camera, a little tiny camera. I'll pop it out of its beautiful silicon holder. It's this big. It doesn't have a viewfinder. It doesn't really have that much interface. It has one interface, which is to turn it on. And there's another button here, which looks a lot like a shutter button. It kind of is, but it's also a voting button. And the reason it's a voting button rather than a shutter button is that inside this is a tiny machine intelligence, and it's a tiny machine intelligent photographer that initially is trained on thousands and thousands of images that were collected by expert photographers that we worked with in Google to kind of curate this body of things that humans tend to like. Other humans, generally. Puppies, sunsets, things like that. Out of the box, that's what it thinks humans like. But as you start to vote on what you like and the people that are in your life, it starts to learn those. Crucially, all of that machine intelligence is on the device. This will work if you go on a hike through rural Japan. This will work without any network. It will do all of that machine intelligence without any connection to the cloud. And I'm going to talk a little bit more about that. Oh, here's crucially some of the output that you get from something that doesn't have a viewfinder. You tend to be in it a lot more, which is kind of the point of a product. Because you've got this kind of little robotic photographer looking out for things that you might enjoy, you can actually be in the things that you can enjoy. Other things that we've done, in the Pixel phones, this is the only segment which is a bit like a Google advertisement, I'll let you know. In the Pixel phones, we have something which is called Now Playing, which is, again, another little neural network, which is on device completely. It recognizes about 72,000 songs by their audio fingerprint. Because they're neural networks, they're just basically numbers, so incredibly small. So you can fit that 72,000 song database in a very small amount of memory, and it can be running constantly. And so the phone wakes up and goes, can I hear anything? Yes, no, pachinko, pachinko. Down the neural layers to the next one, the cascading neural, these are actually cascading neural networks. So it says, I can hear something. Does it sound like music? Yes. Okay. Does it sound like heavy metal? Yes. Okay. Does it sound like Bring the Noise by Anthrax and Public Enemy or something? I don't know. Does it sound like crossover rap, hip-hop, heavy metal? And so then it delivers at the end what you're actually hearing. All of this happens on device, and it can only happen on device, really, to deliver that experience, because it's on device. First of all, you don't have any sort of latency. You don't have any delay in having to go to the network. Also, because it's on device, you don't have to send anything anywhere. If you have to send an audio stream, a stream of any sort of kind of media of any kind, suddenly you're sending lots of data which would impact your plan. And thirdly, it's on device, it's private, it's under your agency, it's in your control, it's in the palm of your hand. So our group is very invested in developing these technologies. The other thing, I just really like this GIF. There is a point to it. This is where we sort of get into the drawer of cables. Anyway, the other thing that I'm going to talk a little bit about is how a lot of the things that we're doing, a bit like Now Playing, they're not like the common, the cultural imprint of what artificial intelligence is a sort of artificial brain. It's, a sort of human-like intelligence. But we have neurons, we have thinking all over us. We have neurons in our knees, we have neurons in our stomachs, we have neurons in our skin. And a lot of the sort of neural networks that we're sort of making for our hardware are more like, knees than brains. They're things which are more like reflexes or sort of autonomic processes than robotic minds or kind of artificial intelligences in the sort of pop culture sense. And the last thing I'll talk about in terms of things that are in cases that are out in the wild, if you like, is a bit like a knee, in a way, like a really sort of autonomic process that we developed with colleagues in DeepMind, which is an adaptive battery neural network, which is learning what you're using at what sort of time. It's all happening on device. Nothing is streaming to a cloud about that data, but it's able to optimize the battery life in your phone enormously as a result of making these sorts of predictions about when things on the device should be switched on and switched off, spun up, spun down, et cetera, et cetera. Who knows this chap? This is Kevin Kelly. He's a Californian technologist, writer, semi-mystic, lives in a very nice house in the countryside and writes books like this, What Technology Wants, and because he lives in technology, he uses phrase like, lives in lives in technology, lives in California, almost the same thing. Writes books like this called The Inevitable, which is, it has an awful lot of Californian ideology and techno-determinism within it. But in that, he sort of spins this interesting sort of metaphor or kind of analog of the wave of thinking and expectations and writing and prognostication that went on around the birth of electricity at the beginning of the last century and what's happening around AI right now. And he sort of talks about this process as, the process of electrification. We're now going through the process of cognification, he calls it. So the embedding of all of these little neural apps and machines in the world will become as distributed as the electric motor and the generation of electricity in our world through the 20th century. And I find that a kind of interesting thought experiment to examine the parallels of. We have, if you like, right now, the sort of equivalent of the centralized power station of cognition, of machine cognition, the data center, the data farm. This is one of ours. Other data farms are available. Try and stop the Google plug. This is a very nice one, however. It has a mural by Jenny Odell on the side of it, which I was tangentially involved in. But we're moving to a sort of more distributed model of where the thinking happens. And that's kind of broadly what my team is involved in, as I said. So kind of moving from just a sort of centralized architecture of where machine intelligence can and will happen to a more distributed model, more edge cognition, and you should never certainly project predictions in front of a room of people and have it recorded on the internet. But this is, I feel pretty safe in sort of saying this and pretty corroborated in saying this, that these things are going to move more and more to be prosthetic to ourselves and be also crucially kind of self-sufficient. This is work by colleagues in Verily, creating sensors which are powered by human body heat. And so in terms of every sort of way in which these kinds of things can be pushed to the edge, become more distributed, more ambient, not just in terms of kind of the way that they work, but the way that they're powered, that's going to come into being. Last semi-advert. This is another thing that our group is involved in, which is a program called AIY. And we sort of take things like the chip, which is in the Google clips for Movidius 2540, I think it is, which sort of runs this machine intelligence, and we put it into cardboard kits that makers can start to play with. I'm going to let my colleague James explain it. Hopefully the sound is working. Let's see. This is the silent bit, I think, hopefully.
So the whole point of the AIY project team at Google
can we have the sound up?
Build artificial intelligence kits that let makers take the cool parts of Google Intelligence and put them into their builds. Last year, we released the voice kit, which was a kit that lets you record your voice and analyze it and get the text back from what you said. This year, we're releasing the Vision Kit. It does not need an internet connection. It does not need the cloud. You program it with the neural network model, and the kit then gives you back data on what it sees. So if I give it a face, the light will come on, and then as I get happier, the light will change from blue to yellow.
CPU, central processing units, and you're probably familiar with GPUs, graphic processor units, used to create advanced graphic performance in sort of desktop PCs and laptops, and more latterly GPUs, because of the sorts of ways that they compute the mathematics in order to render those graphics. They've become very, very popular in order to do the mathematics of machine learning, sort of tensor mathematics. So the GPU manufacturers, NVIDIA, et cetera, have done very well out of the uptick in machine learning activity. The next sort of three-letter acronym is the TPU, the tensor processing unit, or sometimes it's called an NPU, a neural processor unit. And that's an optimization, again, of the chip architecture to make it very, very, very good at doing the sorts of mathematics involved in the cat or dog pinball machine that we showed at the front. Crucially, these are chips that can run at very low energies to do that. The GPUs that you might be familiar with need fans, and they need a lot of electricity. These are very energy efficient, which means that they can go mobile and can be put in little cardboard kits that detect whether you're smiling or not. And what we're sort of releasing in terms of that is this thing up here, which is it's about the size of an old-fashioned memory stick. The top of it, which is all aluminium, is a heatsink. This is an Edge TPU accelerator, which you can plug into a Raspberry Pi or anything that can take a USB-C to accelerate how you can do machine learning at the edge. And my colleague Pete Warden wrote a really good post about all of this called Why the Future of Machine Learning is Tiny. I should point out this is not an enormous coin. Those are very small chips. But in Pete's blog, this is sort of a, if there's one cable in that cupboard that I want you to sort of take with you, is that the physics, as he writes here, the physics of moving data around takes a lot of energy. As soon as you have to spin up a radio in order to transmit that data, you've almost lost. If you need to stream that stuff to the cloud, you're going to use a lot of energy. Before you even get to the concerns about privacy and all the rest of it, you're going to use a lot of energy, and you're going to create a lot of latency. And so, as he says here, the way in which, the reason I'm dwelling on the material of the chips is that this is going to force a change, I believe, in the architecture of how we sort of build the web and build this web of AI. Because the relative gap, as he says here, between the cost of compute in terms of energy and radio is going to get wider and wider and wider. These things are going to get more and more efficient, both in terms of energy and processing capability. Radio is going to always have this kind of giant jump in just sort of energy use it's going to demand. So as this gap gets wider, we'll start to see a sort of change in the distribution of where these things happen, which brings me to this very famous set of diagrams from the birth of ARPANET and the birth of kind of the internet, and after that the web. And so, if we reflect over probably the time that I've known Brian, we've gone from this sort of dream of a distributed or even decentralized web to something which is much more like a centralized set of stacks that we all participate in. This is a quote from an architect, Christian Benimana, a brilliant architect, who when we were talking, said this brilliant phrase, which I think we've heard variations of from many, many people. But the architecture is never neutral. The way in which we sort of think about the way the power is distributed in these networks is something which is very much on people's minds right now in 2018, right? So just a connection I would hope that you can make, it might be forming in your mind, is what the new materials of providing machine intelligence to the edge could start to do to the fabric of the internet and the web. I said that was the last Google plug, but this is published open source research, so maybe it's not that bad. One of the other things that my group works on is a technique called federated computing or federated learning, and this is another little clip to explain that, which will hopefully play.
Machine learning on Google Cloud is a secure way for making products smarter over time. The power of mobile devices has allowed us to improve privacy by running machine learning directly on your phone. So, your phone will quickly feel even more personal. And it's better for your data plan and battery life. Federated learning is a new technology that enables your phone to learn from other devices while keeping your data private and secure. Here's how it works. First, your phone downloads a generic machine learning model. After your phone personalizes and improves its model, it computes a summary about the changes. Thousands of summaries are anonymously combined when phones are plugged in at night. This provides a global improvement to the model that makes it work better for everybody. So you get a smarter phone, and your data stays in your hands.
The maintenance of these kind of like centralized models has always been sort of maintained as something which gives a sort of edge to these kind of very centralized kind of power structures. But in federated computing, you start to see an alternative, which is that you can have on-device machine learning, which is then combining through this kind of, almost like Jungian collective consciousness of phones. That wasn't in that was rejected for that script. But when they're plugged in at night, they sort of dream, but they dream in a sort of privacy-preserving way. And actually, the more phones join this, the mathematically more private it becomes through a technique called differential privacy. And so that kind of centralized model can then come back down and sort of raise all the boats, if you like. And so again, the sort of these changes in the sort of techniques of how these computer science operations happen, we're going to have these profound changes, I hope, on the way that power is distributed through these networks. Little detour. If you are of a certain vintage, and you are a designer, you may have been in a meeting where a client says, "Can you sort of, make it like that movie?" And you're like, "Dude, you came in to like talk about an email newsletter." But you're like, "No." So, and you have to like convince them it's not, not the best way to do it. But now, kind of like the new version of it for the next decade is, can you make it sound a bit more like Scarlett Johansson? This is a still from her, if you haven't seen that movie. This is the new movie which we're sort of under the yoke of. And there's something very old and powerful happening in this sort of thing. Again, it's this sort of like, it's the cultural dreams impinging on the sort of technical realities. We've had this in this poster from the Science Museum, they say the 500-year quest to make machines human. I'm guessing, based on them showing sort of automata and things like that from in the museum, but it's even older than that, right? It's kind of Pygmalion and sort of ancient Greek myth. And I think kind of like this drive to sort of map kind of creating fake humans onto kind of what AI can do. It is almost doing more harm than good. And this sort of brings me back to the menagerie at the top. And I've sort of been very interested in looking at kind of the diversity of intelligence that is on the Earth as a model for how we sort of think about what we're doing. This is a book which I read last summer, which is fantastic. Has anybody else read it here? It's called Other Minds. It's by a chronic overachiever called Peter Godfrey-Smith, who is not only a philosopher but also a marine biologist, who hung out with octopi in the Barrier Reef in Australia, and sort of was fascinated by the intelligence that he saw in octopi, and how it behaved very differently from human intelligence or even mammalian intelligence. And octopi are these creatures which we share an ancestor with billions of years ago. The last common ancestor between us and the octopus is sort of like some kind of like nematode worm of some kind. And so effectively you can see it as a completely alien, separate development of intelligence through evolution on planet Earth. And so by studying this, he sort of finds all sorts of interesting new ways to sort of think about intelligence and think about thinking. And sort of the octopus sort of sits over here. The arms of an octopus sort of act as independent actors, independent entities. He sort of talks about it as being more like a jazz band collected in sort of like one creature than being an individual entity. This is where I sort of make you feel good again with some puppies. And Brian talked about one of our obsessions at BERG, which was being as smart as a puppy. That comes from a quote by Rodney Brooks, the MIT roboticist, where he said, if artificial intelligence is terribly overhyped, if you put the 50 smartest people in a room for 50 years, they'll be lucky if they can make something as smart as a puppy. And we were like, great, puppies are awesome. We should totally go for that. But the sort of obsession with puppies sort of extended to then sort of thinking about our relationship and the Dewi's, why did I apologize for that happening? So bloody British. Anyway, Dewi's talk sort of made me sort of, there's a sort of accidental connection, but kind of the relationship that we have between working animals and ourselves and the way that they extend us, both in terms of like literal power, whether it's a horse plowing a field with us, or a sheepdog in terms of both kind of like locomotive ability, being able to get around the sheep and run around them, and also sensory capability. And sort of thinking about kind of like these companion species approaches was something which was very dominant in the conversation at BERG. I'm just going to point you to the work of Donna Haraway and her companion species Manifesto there. But in there's something that has really stuck with me, which is about this notion of, which I can never pronounce, reciprocity and rights of access between these entities, and the sort of power relationship which is between a companion species and its owner, or its kind of human companion. If I have a dog, my dog has a human, which I think you can extend even further in fantasy literature to kind of the world of Philip Pullman, which I hope some of you at least are familiar with. Who here has read the Philip Pullman, His Dark Material? So in there, if you haven't seen it, then every human being is made up of two creatures. One is the sort of generally quadruped that we are right now, and the other is an animal, a spirit animal, a demon that sort of is their sort of inner voice, their conscious, and it's a brilliant literary trick by Pullman for storytelling that the inner dialogue is actually played out between two characters, but you also have this idea of a sort of you're always like A/B testing the world between sort of these two creatures that have very different views on it. And this thing is, it's me, but it's not me. It's not an assistant. It's not Siri or Alexa or the Google Assistant. It's me, but it's not me. It's kind of separate from me. It's something that I can have a dialogue with, which is where this is going to get really weird. Sorry. Who's familiar with this book? Anyone? Okay, so this is sort of a controversial book, but it's about where consciousness comes from. And Julian Jaynes in sort of like late 60s, early 70s was writing about kind of the relationship that early humans had with nature, the environment, and why gods were invented. And his sort of thesis was, yeah, exactly, was that these were me but not me. Gods were God voices in your head trying to relate to the complexity and the challenges in the natural world around them and turn them into the voices of things which represented or were literally avatars of these very complex systems that they had to kind of model and sort of navigate. This sort of like traveled through to kind of classical Greece and this guy Socrates and his kind of conception of the eudaimon or eudaimonia, this kind of you get to a sort of godlike state through listening to or being protected by a benevolent deity that is yours and yours alone, a kind of personal god or a personal demon that is kind of looking after you the whole time. The eudaimon whispered advice and opinions in one's ears, and it was said that the demon warned Socrates of threats and bad judgment, but never directed his actions. I have another theory about this, that there was some other stuff involved, but we'll go into that another time. This is my connection to the web, talking about spiders. I just wanted to, again, another lead in the drawer of cables in the kitchen, a piece that I read in, I think last year, about some work that zoologists have been doing, looking at kind of the cognition of spiders and how they actually they sort of did a series of experiments which proved that spiders' brains or cognition is partly made up of the webs that they spin, that their external apparatus is part of the way that they think. And in this story, this quote, "It's conceivable for cognition to be a property of a system with integrated non-biological components. That seems to be where we are headed." I would point you at the work of Professor Andy Clark of the University of Edinburgh, who's written a lot about this very fascinating way of thinking about kind of how our tools, our systems, and ourselves are extended by, our thinking is extended by the tools and systems of technology we weave around us. Seems probably very natural to the people in this room, but actually looking at it at a very low level of cognition, which Andy does in terms of experimental psychology and philosophy, is super fascinating. And I just wanted to drop this in here. This is a quote from a brilliant speech by Douglas Adams called Towards a Digital Biota, and which he sort of subtitled before, Ages of Sand, where he talks about kind of the ability of humans being extended primarily through sand through the centuries. First in terms of building materials, then in terms of sensing materials for creation of optics, advanced optics, the grinding of silica into lenses, and then the creation of computer chips, semiconductors from that sand. And then lastly, the final age of sand, the fourth age of sand, the creation of networked computing through glass fibers. I will murder this if I try and read it, so I'll let you, please go listen to this talk. It's absolutely fantastic. That was slide 42. There's the flashing image, which leads me into the downhill slope, if you like. 1945, as we may think, Vannevar Bush's prescient essay about the Memex, the networked machine that would store and retrieve and organize knowledge, which I think a lot of people in this room will know about, which I will segue into talking about hawks somehow. But another book I would recommend to you, which was actually recommended to me by my partner Kelly, who's here, H is for Hawk, is a beautiful, beautiful book. Has anybody here read it? Okay. It's a memoir about grief, about training hawks. But in this, she talks a lot about, again, a sort of companion species relationship, and particularly about the difference between her intelligence, her experience, and that she believes that the hawk has, which she can only ever project into, right? She can only write or think about in her own human terms. What is she seeing, I wonder? My brain does backflips trying to imagine it, because I can't. And so this is kind of, where I think the active design, the active bridging that was talked about this morning kind of comes in, is trying not to make these things, fake humans, but actually building these bridges to diverse forms of intelligence and seeing and experiencing to extend our own abilities. This is a film done by an old BERG colleague, Timo Arnold, which we made in a studio called Robot Readable World. And it's a collage of basically machine vision video. We were trying to get ourselves into the headspace of how computer systems see, and what they see, what they pay attention to, and what's behind that. What are the sort of impetuses in terms of kind of control and power and surveillance and sort of process control and all of these sorts of things which are behind these sorts of emergent aesthetics. Because at the time we were doing a project for Google, which was about making lamps that see. This is one of these things which is like from like 2010, 2011, and you're like, bloody hell, like we had to do all of this with like, and now we can just do it in like ARKit or something, or ARCore. Yeah, horrible to sort of think. But also, kind of in terms of like the cavitation I think happens to our brains as well when you sort of get the sort of whiplash effect of looking at the past and sort of thinking, well, that was 8 years ago. We had to like homebrew all of this stuff, which is now in our pockets and now in the hands of, billions of people around the world, which is kind of amazing. And again, we were sort of like trying to experiment materially here and understand both the material of machine vision and also the material of light on other materials in the world. And if that was mediated by computer, what might that be like? So we were doing lots and lots of kind of like little video sketches to kind of try and get beyond a sort of intellectual understanding of the material. Something I think we heard from Charlotte and Nina, particularly this morning. Just getting it under your fingernails as quickly as possible was the most important thing. This was kind of like looking at how projected light on different woods and materials kind of like changes the character and the sort of grain and appearance and sort of your reaction to it, which then sort of led to kind of speculative designs like this wooden Spotify player, basically, before its time. These are fiducial switches, which we could recognize in a simple computer vision program. We painted them in using a dye that you couldn't see with the naked eye, but a computer vision, it fluoresced in the infrared, so a mobile phone camera could see it. And then we started projecting, kind of like, if you've seen those kind of like big sort of light projections that you see on buildings, we tried to do kind of like mini desktop version of that to make these kind of like really I mean, when they're projected, they look, when you see them in the real world, you don't know what you're looking at. They look so weird and magical. It's amazing. And this was kind of like just a sort of exploration of what would happen if you had very dumb objects made out of blocks of wood, effectively, that could be recognized by computer vision, and very smart light, if you like. And what's kind of interesting, looking back at that for me, is like that's coming from an assumption about the architecture that it's going to be centralized and the light is going to be smart and the things that you own are going to be dumb. And now we hopefully are perhaps correcting the pendulum swing to more of a, the objects that you own are going to be smarter and smarter, and they're going to work in conjunction with a sort of a smartness in the sky, if you like. Which brings me to the last animal, the centaur, and this guy, Garry Kasparov. How am I doing for time? Terribly, sorry. And he was famously and controversially, from his point of view, beaten by IBM's Big Blue, touted as a sort of artificial intelligence back in the late 90s. But he came away from that and sort of said, okay, well, I think it defeated me when I tried to think like a computer. I did best when I thought like a human. And he came away from this and started to develop a form of chess which was about teams of humans and computers working together to play against other teams of humans and computers, which he dubbed centaur chess. And we sort of see this kind of pattern becoming more and more part of the technology that we're creating, this kind of centaur pattern. So in Gmail, you have kind of like, whether this is like terribly rude or terribly useful, I don't know, that's up to you. But you have things like Smart Compose, where it's completing phrases which you would often type. Is it an affront to your friends if you don't type "looking forward to see you" yourself? I don't know. But it is kind of useful. This is Robin Sloan's work. He's been experimenting with this kind of like partnership between machine intelligence and himself in terms of creativity over the last year or two. He wrote a blog post called Writing with the Machine, where he's kind of doing that kind of smart compose, smart complete thing with a machine that's been trained on pulp science fiction of the last 40 years. So it's kind of a way for him to both kind of like break writer's block and maybe avoid cliche. He writes brilliantly and speaks brilliantly, much better than I ever could. And I probably will skip this video in the interest of time, but it's on the net. This is one of our experiments by our folks in a creative lab around duets between an AI and a human producing music. But I will show this one because it's a little less, perhaps has a bit more of a important outcome. This is a sort of duet between a nuclear physicist and a machine intelligence trained in nuclear physics to create fusion reactor architectures. This was done by colleagues in Google AI Research in a group called Google Accelerated Science. And in this, they've created something which they call the optometrist algorithm, which suggests, again, A/B tests in a way with the human expert in the way that an optometrist talks to you. Is it better like this? Is it better like that? Is it better like this? Is it better like that? And because the expert human has this kind of like multi-dimensional intuition, that he can sort of say, yes, that's better, in a way that is like much beyond what the computer can do, but the computer can generate that multi-dimensional possibility space much faster and with much more veracity of sort of simulated mathematics behind it. The combination of the two gets incredible results, like hopefully pollution-free energy for the rest of humans' lifespan on the Earth. So coming back to the end, I suppose, the God voices are coming back. They will be, I hope, our extended self rather than an assistant or an other that we give commands to or have sort of like a weird othered relationship with. I'll let this guy perhaps speak to that.
I think one of the things that really separates us from the high primates is that we're tool builders. And I read a study that measured the efficiency of locomotion for various species on the planet. The Condor used the least energy to move a kilometer. And humans came in with a rather unimpressive showing about a third of the way down the list. It was not not too proud of a showing for the crown of creation. So that didn't look so good, but then somebody at Scientific American had the insight to test the efficiency of locomotion for a man on a bicycle. And a man on a bicycle, or a human on a bicycle, blew the Condor away, completely off the top of the charts. And that's what a computer is to me. What a computer is to me is, it's the most remarkable tool that we've ever come up with. And it's the equivalent of a bicycle for our minds.
There's a spreadsheet maybe there. So I think, I want you to sort of move beyond kind of thinking about assistants as the model for where this stuff is going. Move beyond Scarlett Johansson. Move beyond all of the kind of like 500, 2,000 year stories we've had about kind of what artificial intelligences will be like, and think about it something which is an extension of ourself. So if we sort of go back to this, it's kind of, building the suit rather than building Jarvis. Rather than build, Jarvis exists in those movies in order to basically explain the plot. Google got on this kind of like jag of like making the Star Trek computer. They speak to the computer in Star Trek because it's a television program, and it would be very boring if Worf dispatched the enemies by typing some commands into it. Also, why is Data typing? Anyway, we can do that later. So we're kind of I think where we're heading to is a world where we're making more Iron Man suits than we're sort of like making kind of robot butlers to talk to. But they both have a place. I am very much invested in working on this well, not really Iron Man suits, but and things that are made by Google, the hardware that's going to get more and more smarts in it. There is also a place for the big robot in the sky that kind of like collects everything together and you ask questions of. That's not going to go away. And lastly, this is something my boss said to me, is kind of, well, where are the limits of agency in this? If you wanted to, command this extension of yourself to extend yourself to do something like this, where do the ethics lie in sort of what you're making here? So, a last like that movie thing to think about would be the relationship between personal AIs, these kind of extensions of yourself, and the world itself. Because I think one of the things that's going to happen is they're going to become this kind of companion species to ourselves, going to be working on the same surfaces, the same tools as us, with us. We already have this in terms of fly-by-wire or drive-by-wire systems in complex aeroplanes or trucks, those sorts of things. There are companion species, if you like, in the Boeing planes, which can sense wind speed and wind shear on the wing, which humans cannot. But they work to turn the plane with their human pilot. So I think, this is like if I wrote blog posts or Medium posts anymore, this would be like the weird controversial clickbait thing I would put at the top is, should we start thinking differently than thinking about user-centered design, and think differently about the words that we're using in terms of the ways that we try and paint the relationships between the tools, the environments, the systems that we're working? I think so. I think it's going to be more fruitful if we do than just thinking about kind of a user at the center of this web. And I think, we obviously in 2018 have to think a lot about the choices we make in terms of the power dynamics we make in our tools, which leads me to two final books. Bruno Latour's Reinventing the Social and Donella Meadows' Thinking in Systems, both of which kind of posited in the 1970s and 80s a much more complex but practical way to engage with multi-actor, multi-dimensional webs of how systems work, rather than this kind of, if you think about the kind of centralized view, back to that Paul Baran diagram of user-centered design, thinking about a distributed web of how influence and power flows in these systems is incredibly important. And I'll leave you with the words of Ivan Illich, who informs a lot of what I do, sort of thinking about kind of tools and what the difference between tools that create these kinds of centralizations of power and tools for conviviality. He writes that tools for conviviality enlarge the range of a person's competence, control, and initiative, limited only by other individuals' claims to an equal range of power and freedom. That is gold. That's the best cable in that messy drawer, for me at least. So thank you very much. Sorry I've gone over time. Hopefully something interesting or useful in there. Thank you.